Well, in the previous video, we saw how memory leaks occur and how we detect them using Valgrind and the analyst tools. Okay, so address sanitizer tools and stuff. So that was about detection of memory leaks. Okay, so this is totally a manual process. Okay, so like you forgot to write over here, so like that was how we projected the problem. Okay, but in real world the part is not about forgetting to write the delete. Usually people don't forget to write anything likewise. Okay, so ideally what happens is you have some kind of code in between your allocation and deallocation. Okay, so consider that the code you have written between your allocation and deallocation has some kind of an exception which occurs in the runtime. So that also leaves you with memory leaks. Okay, so for that purpose we have in C++ something called as RAII. So RAII basically, like I said in the previous video, is resource acquisition is initialization. So basically it's an idiom. Okay, so let me tell you briefly about the idea of RAII. So RAII basically allows you to tie the acquisition of a process, okay, like of a resource, sorry, not a process, a resource, like you could say memory, file handles, locks, or any sort of resource with the lifetime of an object. Okay, so in the previous video whatever we had seen, we didn't create any object or any sort of a thing. Okay, so we'll, what you say, refactor our program. Okay, so that in terms of RAI, so as I said earlier, so RAI basically ties your resource allocations with the life cycle of an object. So when you want to acquire a resource, okay, you do it at the constructor. Okay, and when you want to release the resource, when the destructor is called. Okay, so this is the basic, you could say, the fundamental idea behind RAI. So whenever you are acquiring a resource, do it at the constructor. Whenever you are releasing the resource, do it at the destructor. So you write your acquisition code at constructor and release code at destructor. So fairly simple, but even in those cases, okay, so if you have not implemented your copy semantics or move semantics properly, then also this simple thing will not work. So that is why we use something called as smart pointers. So specifically in this case we'll be using unique pointers. Okay, so let me just refactor this program, as we have done enough of blabbering. Okay, so just comment this thing for now. Okay, sorry. So firstly I am going to write a non-RAI version. So I'll just name this class non-RAII. Okay, so just to show you like how different these things are from thing, and how in modern C++ we have modern constructs that allow us to write secure programs. Okay, so public, private I am writing only for now. Okay, and here is the resource that we are going to allocate dynamically. So int star data. Okay, and as I said earlier, for the RAII, like this is a non-RAII, as I told you earlier, that this is because this class will not implement the copy constructor or the move semantics thing properly. So this will be a non-RAI version. Even the previous version that we had written, that was also a non-RAI version, but it was totally into this, what do you call, a procedural way of things, so we are just putting it into a object oriented way. Okay, so just take the constructor, sorry, and here I'm going to write data is equals to new int 100. Okay, so here I'm allocating 100 slots for this thing, and destructor, so this will be called when the object goes out of scope. Okay, so again there's an issue with calling destructor explicitly. Okay, so better approach is to tie it with unique pointers, so that also we'll see, just a example that I'm showing you now. So I'll just create an object of this thing, non RAII, NRI, we'll name it now, and that's it. So like simply we have created and deleted. Okay, so this was the non RAII version. So how things differently we will do with the RAII version. First we will see if this thing compiles or not. So that's not CPP test. Okay, it got compiled. Okay, so this was the non-RAI version. So at this point you would not see much of a difference. Okay, so just focus on the conceptual things that I'm telling you. So now what I'll do is, below this only I'll create a RAI version, just so that you can spot the difference with your eyes. Okay, so public, private, and here I'm doing something different here. So std unique ptr, unique ptr. Okay, and here I'm going to write int, and this is a kind of an array allocation, so that is why I'm writing this open empty brackets. Okay, so now you will see it is showing red wavy line, so we are missing an import. We'll add memory.h. Okay, to use this feature you'll have to use memory.h, include memory, sorry, not memory.h, memory. Okay, so that should get rid of this thing. So this header will help you to get rid of the red wavy line. Okay, and now we'll write simply the constructors again. Okay, here we'll be using a different sort of a constructor. Okay, so this is the kind of modern constructor. So like if you are using classic C++, so this is again a modern CPP feature, you could say. I'm not sure if it is a modern feature or not. So yeah, this is pretty much a modern feature, yes. So make unique, and here we will be writing something much difficult to write usually. Okay, hopefully I have not missed any brackets. Yeah, so this is the difficult part, and here if you see I have not written any destructor. Okay, so like I said earlier, the previous version that I have written over here, non-RAI, I said that it suffers from copy semantics and move semantics issues because we have not implemented the copy constructor, okay, or the move constructor as well. So why do you think the same issue doesn't happen here? The reason being, this is a unique pointer and this is non-copyable, that is, it cannot be copied. So there is no way you can copy this. Okay, so for that, if you are planning to copy something, you cannot use a unique constructor, unique pointer. Okay, so that is why this version, RAII version works properly. Okay, so this also will create another instance. Okay, I forgot this thing, semicolon. So after your class you have to write a semicolon, just don't forget it. Alright, okay, so again we'll compile and see if we are missing something. Yeah, it is working. So we have not yet run this thing. So even if we run this thing, there's no difference as such that you will be getting. Okay, so this was just an introduction to show you how RAII is implemented. Okay, so here I have taken the simplest approach using the unique pointers, because what I'm planning to do is we'll have two videos with RAII. This is the first one. In the next video I will show you how you can implement this RAII thing along with this copy and move semantics thing, and what all issues you will face in those aspects as well. Okay, and then we'll appreciate the features of unique pointers. Then there are shared pointers and weak pointers. Okay, so those are the upcoming videos that will be lined up. Hopefully this was helpful to you guys. Okay, thank you.